Hi everyone! Today, our group will present our database project, which is Customer Feedback and Review Management System. This system is designed to help companies to collect, manage, and analyze the customer feedback in more structured and efficient way. By centralizing feedback, the system allows the company to understand customer opinions, identify areas for improvement, and enhance their service quality. I will first introduce our group, and then we will move on to explain the system in more details. Before we begin, I would like to introduce our group members. My name is Tosha Chen, and I'm the group leader for this project. I was responsible for coordinating the overall project progress and ensuring that all components were complete according to the requirements. The other members of our group are Tuen Han, Ho Ying, and Li Jiming. Each of us will cover the different part of the system report, including introduction, problem statement, objective, entity relational model (ERD), normalization, data dictionary, beginner SQL, intermediate and advanced SQL, and lastly the conclusion. With that, we will now proceed to the main content of our presentation. I will pass the next section to Jimmy.
Thank you, Shi-Chen. Hi, I'm Jimin. Now I will talk about the introduction of our project. In this project, we implemented a database for a customer feedback and review management system. The system is designed to help companies understand customer needs by collecting reviews and ratings in one centralized database. Customers can submit feedback and give ratings from 1 to 5 stars for purchased products, while staff members can review and respond to the feedback. This allows staff to understand customer satisfaction, identify areas for improvement, and analyze product performance based on feedback and ratings. The system consists of 5 main entities: customer, product, feedback, response, and staff. Each entity has a primary key to uniquely identify records, ensuring the data is well organized and easy to manage. Thank you. Now I will pass it to Yan Han.
Thank you, Jingming. Hi, I'm Yan Han. Now I want to talk about problem statement. Customer feedback is usually mixed up and confounded, so it becomes difficult to extract the most important insight. If there is no definitive and arranged procedure, replies get slow and varying, thus trending, and customer satisfaction will not be easily managed. Consequently, customer will have the impression that they are ignored, the bonus input will not get to the right people, and the problem that have not been resolved will remain. Next, I will continue talk about objective. The objective of this system is to accumulate consumer opinions on a single platform and provide quick and uniform replies. It gives management a transparent view of customer happiness, facilitate interdepartmental communication, and collaborate with customer feedback to the point of satisfaction improvement. Now I will pass it to Hui Ying.
Thank you, Yan Han. Hi, I'm Hui Ying. Let me explain the entity relationship diagram for our customer feedback and review management system. We've visually mapped out how we capture, manage, and act upon the reader input for our customers. At the heart of the system, we have 4 core entities: customer, product, feedback, and staff. The process begins with customer and product, where a customer can give feedback on 0 or many products, and a product can receive feedback from 0 or many customers. This many-to-many relationship is modeled using a composite entity, feedback. Each feedback record ties on one specific customer to one specific product. Feedback then initiates the conversation handled by staff. Each feedback can have multiple responses, such as a thank you, a follow-up, and a resolution. Every response is linked to one feedback and created by one staff member, ensuring clear accountability and a complete audit trail from customer comment to team action. In summary, this system connects customer and product through feedback, then feedback to staff through response, ensuring full traceability. Technically, the staff-response relationship is weak because response rely on staff for creation but derive their core identity from the feedback they respond to, ensuring clear accountability and data integrity. That's all for the ELD part. Now I'll pass it to Jingmin.
Thank you, Hui Ying. Now I will explain the normalization of our database. Normalization is used to organize data efficiently and to reduce redundancy. In this project, our database is normalized up to third normal form. First, in first normal form, all tables contain only single values in each field and there are no repeating groups. Therefore, our tables already satisfy first normal form. Next, in second normal form, no attribute is dependent on only a portion of the primary key. Each entity such as customer, product, staff, feedback, and response has its own primary key. And partial dependency is eliminated and is specified second normal form. Finally, in third normal form, there are no transitive dependencies. All non-key attributes depend only on their respective primary keys. As a result, our database design is well structured, reduce data redundancy, and improve data integrity. Thank you. Now I will pass it to Yan Han.
Thank you, Jingming. Now I will talk about data dictionary. The data dictionary in our database is a set of tables and attributes which describe the data type, format, and acceptable range. It acts as a support for data consistency and enable the system to handle data with precision. One of the major tables in our database is the customer one that contains customer information, the product table that has details about the product. Feedback given by customer is also recorded in the table, and this table connects the different data as well. In this table, foreign keys are assigned to customer ID and product ID that bind the feedback to the respective customer and product. Staff table has information about staff, and the response table records the staff's reply to the feedback. Feedback ID and staff ID are foreign keys in the response table, which link each response to the connected feedback and the staff member who responded. To identify the record uniquely, every table has a primary key and relationships are formed through foreign key. This not only guarantees the accuracy of data, but also inhibits entering of any incorrect data. The data dictionary thus forms an efficient data management in the system by making a clear structure of the database. That is all from me. Now I will pass it to Hui Ying.
Thank you, Yanhan. Me and Shenzhen will now demonstrate the SQL part. SQL is typically divided into 3 learning levels: beginner, intermediate, and advanced. I will begin by demonstrating the beginner level SQL commands. Since we have already created all the tables and inserted the data into the database before, now I will show all the tables by select all from the specific entity. This is the first entity, customer table. This is the product table. This is the staff table. This is the feedback table. And lastly, this is the response table. For example, when we want to find all feedback from a specific customer ID 00101, we can use this command. Where is to class filters rows and require both conditions to be true and then display the correct output. Next, to list the customer in reverse alphabetic order, we can use order by. DESC is to make the customer name in descending order. So this is the result. In addition, we also can find the staff whose name started with S. The like S pattern is to search for any name starting with S. This output shows Sarah because her name matched with the condition. Furthermore, I will try to change the status of a specific feedback item to resolve. The update is used to modify existing data, set to specific which column to change the where condition must be Unicode. Now, I selected the feedback table to prove that the status is already be changed. Lastly, to remove the customer 00103 from the database, I use delete to remove the entire rows. The SQL told that the deletion is successful, but if we feel confused, we can select all from the customer table to check whether the deletion is successful. That's all from me. Now I'll pass it to Shenzhen to continue.
Thank you, Hui Ying. Now I will continue for the intermediate and advanced SQL. First, let's look at the grouping data. Sometimes we don't want to see every single piece of feedback, we just want a summary. This command groups all the feedback by the star rating and count how many we have each. As we can see here, it gives us a clear amount of how many 5-star ratings we have, 4-star, and so on. Next, we have a subquery. Think of this as asking a question inside another question. We want to find another names and emails for only our happiest customer, the one who gave 5-star ratings. The code first finds the IDs of customers who rate 5 and then use those IDs to pull their contact info from the main customer list. Often, our data is spread out in different places. Here, we use a join to connect 3 different tables, which is feedback, customer, and product. By joining them, we get a single complete view showing exactly who bought what product and what they said about it. Next, let's look at store procedure. This is like saving a shortcut for tasks we do often. Instead of writing a complex code every time a new review comes in, we create a procedure called add new feedback. Now, we just call that shortcut with a new information. As you can see, the system automatically saves the data correctly. Finally, we have trigger. This is used for automation. We create a trigger so that the moment our support team adds a response to a customer issue, the system automatically update the original feedback status to resolve. It happens instantly behind the scenes without us saving to do anything. That's all from me. I will pass the conclusion to Jingling.
Thank you, Xuechen. In conclusion, this project successfully designed and implemented a customer feedback and review management system with a well-structured database. The system allows customers to submit feedback and ratings, staff members to respond to the feedback, and the management to monitor feedback status and overall trends. By applying normalization up to third normal form, the database design reduces data redundancy and maintains data integrity. The entity relationship diagram clearly defines the relationships between all entities in this system. Overall, this system provides a strong foundation for effective customer feedback management and supports better business decision making with potential for future enhancement. That's all from us. Thank you for listening.